This is problem 3 on exam 2 of module 6 in the book Problem Solving Guide for Electromagnetism and Optics. Problem 3, you have a large number of 50 ohm resistors, each of which has a 3 amp maximum current rating. Part A, construct a circuit that has an equivalent resistance of 100 ohms and will pass a maximum current of 6 amps. Part B, construct a circuit that has an equivalent resistance of 60 ohms and will pass a current of 5 amps. Well, let's draw a box of resistors. Here's one resistor. You have to connect a bunch of these to get 100 ohms and pass 6 amps. Well, each individual resistor will pass 3 amps, so we need multiple branches to pass 6 amps. We need more paths, at least 2 branches. So let's start by considering 2 resistors in parallel. Let's not try to get the answer right away. Let's learn. Let's try some things and iterate and increment towards the correct answer. So what goes on here? We pump in 6 amps. This resistance is 50. This resistance is 50. It's going to split evenly. 3 amps goes through the top, 3 amps goes through the bottom. So this circuit will pass 6 amps. That's a good start. But what's its resistance? We have two 50 ohm resistors. What's the equivalent resistance? Well, they're in parallel. Two 50 ohm resistors in parallel is an equivalent of 25 ohms. So we qualified for the maximum current, but we don't qualify for the resistance. But we've made progress. We've learned. We've been exploring the solution space, trying to figure out what we can do. 2 branches of equal resistance are going to pass 6 amps irrespective of the resistance. If you pump 6 amps in, it doesn't matter what the resistance of the branches are. If the resistance is the same, the 6 amps are going to split up 3 each way. So all we have to do is add more resistors to each branch. So we need an equivalent resistance of 100. What must be the resistance of one branch if the combination of the 2 branches in parallel has an equivalent resistance of 100 ohms? So think about it. Don't be a slave to the equation. Let's think. If you think you have an answer, a theory, then you can use the equation to check it. It's 200 ohms. If we have 200 ohms in each branch, we have an equivalent resistance of 100 ohms. To get 200 ohms, we need 4 50 ohm resistors in series, like this. So the top branch has 200 ohms, the bottom branch is 200 ohms. 2 200 ohm branches in parallel is 100 ohms. And if you pump 6 amps in here, 3 will go through each. So this circuit has an equivalent resistance of 100 ohms, and it will pass a maximum current of 6 amps. That's part A. Part B, we're going to need multiple branches, but the resistance in the branches can't be the same because 5 amps is not a multiple of 3. I don't know what to do here. Let's try something. How about this? We have 2 50s in parallel. That makes 25, and that's in series with the 50. So this gives a resistance of 75. That's not bad. We're trying to get 60, and we got 75. That's pretty close. What's going on with this resistor, though? This resistor gets all the current. If we pump 3 amps in here, this guy is going to pump 6 amps in here, this guy gets 6 amps. He's going to burn out. This is no good. You have to be able to pass 5 amps. This circuit only passes 3 amps. Back to the drawing board. Let's try something else. We can't have a resistance that gets all the current. What about this? Let's see what happens here. The top branch has 3 50 ohm resistors in series. That's 150 ohms. The bottom branch has 2 50 ohm resistors in series. That's 100 ohms. So we have 150 in parallel with the 100. The equivalent resistance 1/50th plus 1/100th is 2 300ths plus 3 300ths. That's 5 300ths. Ooh, 5 300ths. 1 over that is 60. Jackpot. We got the 60, but now we have to worry about the current. How much current will this pass? The problem is if you pump 10 amps in here, most of it's going through the bottom. So we have to figure out how it's going to split. It doesn't split evenly. Well, which resistors are vulnerable? If we start increasing the current, which resistors are going to burn out? And the answer is the ones on the bottom, because that branch has less resistance. It's going to get more current. So these guys are going to burn out before these guys do. No matter what current you pump in here, this current is greater. So these will get to 3 amps before the top. If 3 amps is going through the bottom, how much is going through the top? It's less than 3, we know that. How can we calculate it? How much less? One way is to balance the voltage drops. But the voltage drop across those two circuit elements are going to be the same. They're in parallel. If 3 amps is going through the bottom, it has a resistance of 100 ohms. The voltage drop is going to be 300 volts. So the voltage drop across the top set of resistors has to be 300 volts. Total. Since there must be 300 across the top branch, and the resistance is 150 ohms, we can calculate the current. 2 amps. Ooh, that's good, I think. That's it. 3 amps going through the bottom, 2 amps going through the top, that's 5 amps. If we put 5 amps through here, 3 amps is going through the bottom, 2 amps is going through the top. They're going to get back together here. 5 amps is going to be passed. The equivalent resistance is 60 ohms. Que milagro! That's problem 3.